Today we are going to see line coding in digital communication, and this is Vanilla. So baseband representation of a digital data into a waveform for the purpose of transmission from a source to a destination is called line coding, and the various techniques or formats used for line coding are unipolar format, polar format, bipolar format and Manchester format. So first we'll see the unipolar format. So this unipolar format will travel between your 0 to B. So if your data sequence has 0, its value is represented by 0. If your data sequence is 1, it is represented by B. Right? So we'll take a data. So in this data, we'll see two different formats for unipolar. One is going to be the return to 0. So here in this return to 0, the value 0 will be mentioned in the 0, 1 will be mentioned, half of the sequence will be mentioned as 1 and the next half will become 0, that is it returned to 0. So it travels between 0 and then V. Right, so if it is 1, so half will be your 1, the other half will be it returned to 0. Then it is going to be 0, so it remains in the same position. Then it is going to be 1. So 1 means, as I said earlier, so half it will be the 1 and then the next half it returned to 0. And again it's going to be 1. So first half will be 1, the next half it will return to 0. If it is 0, it will retain in the same position, and then for 1 alone it goes back. So again it's 1, so half will be 1, the remaining half it returned to 0. So next is 0, 0 and again 1. So first half will be 1, the next half it returned to 0. So this is the return to 0 format. Now we'll see the non-return to 0 format. It will not return to 0 for the data 1. That is the meaning of it. So travels between 0 and V. So if it is 1 now, all the whole entire period it will be 1. And for 0 it comes back to the 0. And then if it is 1, the whole period it will be 1. Again it's going to be 1. Then it's going to be 0, 0. Again it's going to be 1. Then 0, 0 again. And then it's going to be 1. So this is the unipolar format for return to 0, non-return to 0. Next we'll see the polar. So polar, it travels in between your plus V by 2 to minus V by 2. Plus V by 2 to minus V by 2. So if your data sequence is 1, it is indicated by plus V by 2. If your data sequence is 0, it will be indicated by minus V by 2. So we'll see for the first one for return to 0. So here for this one from plus V by 2 or minus V by 2, it returned to 0 for the next half. That is the meaning of it. So let it be plus V by 2 and this may be your minus V by 2. The first half it will be in the 1, then return to 0. For 0 it will be in the minus V by 2. First half it will be in minus V by 2, then return to 0. Then it is 1, so 1 means it should be in the plus V by 2. So first half it will be in 1 by V by 2 and then it return to 0. Again it is 1, so plus V by 2 return to 0. 0, so minus V by 2 return to 0. Then 0 again, so minus V by 2 return to 0. It is 1, so plus V by 2 return to 0. 0 minus V by 2 return to 0. 0 is minus V by 2 return to 0. Then it is 1, so plus V by 2 to return to 0. So this is your non-return to, that is your return to 0. Now we'll see the non-return to 0. So in this non-return to 0, the entire part will be your in the same position here. That's it. So it may be your 0 or 1. It will not return to the 0. So it runs between plus V by 2 to minus V by 2. And then if it is 1 now, it will be in the plus V by 2. If it is 0 now, it comes back to your minus V by 2. If it is 1, plus V by 2. So 1 again. So 0, 0 again. Then 1, 0, again 0 and again it's going to be 1. So this is your polar. Next we'll see the bipolar. So in this bipolar, it travels between your zero, 0, that is your V and then your minus V. So here what happens, your 0 will be, data 0 will be in the same position Z, but for 1 alone, so for the first one it will be plus V, for the next one it will be in the minus V. So it takes the alternate position here, right? So we'll see this one for the same data. So this is going to be the return to 0. So it travels between your plus V and then the minus V. So for the 1, it will be in the plus V, return to 0. For 0, it will be in the same position. For the next one, so first it should be, it is in the positive, so it will come to the negative polarity. That's it, return to 0. Then again, positive polarity, then 0, 0, negative polarity, 0, 0, then it's going to be positive polarity. So this is your return to 0. For non-return to 0, it will not return to 0. So it will retain in the same position for the entire duration. That's it. So it's going to be 1, 0, then it is minus 1, then polarity change 1, 0, 0, polarity change 1, 0, 0, polarity change 1. So this is the non-return to 0. Now we'll see the Manchester. So in this Manchester, the data sequence 0 will be traveling between your uh, this one. So this is going to be your mentioning of your 0, and then 1 it will be your this way. So this is your half will be this way, half will be that way. So it is in between your minus V and then plus V. Or you can have it as 1 and no problem at all, right? So this is going to be plus V and then minus V. So it travels this way. So we'll see how to get this Manchester. So in this one, I'll be taking this as a plus V and this is going to be minus V. So this is going to be your plus 1. So if it is going to be plus 1 is, it's going to be, initially it will be from plus V to your minus V. And 0, it's going to be minus V to plus V. If it is 1, plus V to minus V. Again, it's going to be 1, so it's going to be plus V to minus V. If it is 0, minus V to plus V. Again, it is going to be 0, so it's going to be minus V to plus V. It is 1, so plus V to minus V. 0 na minus V to plus V. Again 0 is minus V to plus V, and if it is 1 na plus V to minus V. So this is the Manchester code. Thank you guys. Have a nice day.